All right. Hello, everyone. Welcome. Let's begin. Let me see. Oh, well, we have over 60 people. That looks really good. So I think we can totally start. Let me start sharing my screen. And you should be able to see my screen now, actually. Let me know if you can't see it for any reason, but it should be all good. All right, so before we all start, first of all, I don't think we've met. So my name is Lana. I am one of the teachers here. I've been with Careerist for over 3 years, actually. And I usually teach all kinds of lessons that are a little bit technical. If any of you is interested in test automation, you will see me a lot during our QA automation course. But I also assist with manual testing as well. And during manual testing course, I only teach a few classes, including this one, where we cover some pretty technical aspects. A few words about myself. I have over 10 years of experience in QA. I started as manual QA. Now I work as a QA automation engineer, and I currently lead test automation at Reddit. I'm responsible for Reddit NFT marketplace project, and yeah, that's basically it. All right, so what I usually like to do is this. I will just go over, some topics, some content. And if you have any questions, please feel free to ask in the chat. I like to keep the chat open so you can see comments and questions from each other. But if you don't want like anyone else to see your question and you want to send a question to me directly, keep in mind that you still have this opportunity. You can just pick my name from the list of chat participants, and then when you ask a question, I will read it and I will answer it. I know some people are shy, they like to ask questions directly. Feel free to do that. Also, because the chat is open, please be aware of other people. Try to not talk on topics that are not related to today's lesson, because it could be distracting for some folks. So please don't spam too much on topics that are not related to what we're going to be talking about. That's it. So I think we can start. Let me quickly check the chat. Let's make sure we're all good. And yeah, then we can probably begin. Nice. Okay, cool. So I don't see any comments or questions or any people having issues with the sound or video, so we can begin, and let me go full screen first of all. Okay. So today's our lesson number 9. Today we will spend some time and talk about a few things. First of all, we will talk about BrowserStack, which is just one of additional tools that you can use when testing things. And then after that, we will switch to client-server communication. We'll talk about client-side, server-side, how they communicate, and then we'll also talk a little bit about Chrome developer tools and how we can use Chrome dev tools in order to see that. So that's pretty much it for today. We're going to start with BrowserStack, so let's begin. So first of all, BrowserStack, it's just another tool that you can use when you test something. I think by this time you already should be familiar with mobile testing and web testing. So BrowserStack is just another platform that is pretty popular in QA, that a lot of QA engineers actually use in order to test something. So the cool thing about BrowserStack is that it's just a cloud platform that has a bunch of different devices. So as a QA engineer, you can actually connect to BrowserStack platform remotely. You can just pick a device and then you can do your testing. So basically, BrowserStack provides a bunch of different devices and allows us to increase our coverage. Very often, companies will use services like BrowserStack in order to test on some additional devices. Obviously, for an average startup, it's pretty hard to keep a giant device farm with 10, 20, 30 or more different devices. So usually what companies do, they buy some devices for QA engineers, like 1 or 2 phones per person. And then all kinds of additional testing will be done using services like BrowserStack or something similar. So again, most of your testing you will be doing on the real devices that the company will give you, but there is a good chance that some additional testing you will be doing through services like BrowserStack. So I will show you how BrowserStack looks, because I literally just created an account to like give you some idea. But what I would like to encourage you to do is after this lesson, or maybe tomorrow, like whenever you have time, please go to browserstack.com, or you can just use this link on slide number 1 and try to create a free account so you can actually play with that platform, and you will really understand how it works after you actually play with those devices for like 10-15 minutes. It'll be pretty easy. But for now, let's take a look at BrowserStack, because I do have an account. So let me show you what it actually does. So again, I literally just created a new BrowserStack account like 2 minutes before this lesson. So after I register for BrowserStack, this is how it looks, right? So you can see this dashboard with a bunch of devices. I am on the free trial. So if you try to create your own account for BrowserStack, you will see exactly the same thing, the same experience. And here right now, I'm on BrowserStack Live. So Live is a BrowserStack product that allows you to test web. So basically here I can pick a device, like any of the devices I want, Windows, Mac, or other ones. Then I can pick a certain version of operating system. For example, we can go with Windows 11. And then I can pick a browser, and BrowserStack will connect me to that device with that browser running. So I have this page that I wanted to test today. And to test, just like to use as an example. So this is how it looks. It's just a web page that basically like displays this image. It's a little bit broken, but when you open this page, I'm currently on Google Chrome. This is basically how it looks. It's just a page with an image. Right, so now, for example, if I want to test this page on a different device or on a different browser, I don't actually even have to have a different browser installed. As long as I have a service like BrowserStack, I can just use that instead. So I can go to BrowserStack, right? Here, I can pick a device that I want to use for testing. So let's go with Windows, for example, because I'm right now on Mac. I don't have a Windows computer. So let's use Windows here as an example. And then I can pick any browser, and BrowserStack will connect me to Windows device with the browser that I just selected. So for the sake of example, let's go with Firefox. By the way, these numbers over here, they are browser versions. So we usually test on the latest version. Sometimes we test on the latest 2 versions. We usually don't go below that, but BrowserStack gives you ability to even go like further in the past if you want to. But for now, let's go with Firefox 109, which is the latest version. So when I click on it, you can see that it basically tells me that it's starting the browser on a real device. So now it's trying to connect me to a Windows computer with Firefox. So this is it. So this is the machine right now. And then here I can just basically enter the URL. And then I can do my testing. So it will allow me to navigate to any of the websites that I want. So it looks like it's a little bit stuck for some reason. Let me try to reconnect again. Let's go with this one. It sometimes happens. But basically here you can just provide the URL. And then it will take you to that web page, so you can do your testing. All right, so come on, BrowserStack. It was working a second ago. It doesn't want to cooperate right now. There we go. Let's try it one more time. Okay, so for some reason, it looks like they have like some issues with Firefox. Let me try something else. It happens. Let's go with Edge, for example. But then basically, again, you can just like basically paste your website. And after that, you can just navigate to the page and do your testing. For some reason, I don't know, it doesn't want to cooperate with me right now. Do it again. But let's see if version should help. Well, all right, let me refresh that. That's a little bit weird, but usually it works. Anyway, so let me try one last time. If it doesn't work, it doesn't work. I'll just let you do it yourself. Again, it's just like basically picking a browser, connecting to that, and that's it. So let me try one last time. I'm going to try maybe like Windows 10, who knows. And again, Firefox, it sounds like they're having some problems today with this for some reason. It did work before the class, but looks like right now it's just not connecting. All right, so let me try one last time. Okay, here we go. Now it's working. That's weird. Okay, so now we can basically open the URL. Sorry about this. And we can see how our web page, right, looks on a different browser. So right now I am on Firefox. I'm on Windows 10, and this is how this page is displayed here. You can see that this is quite different from what I was observing here, right? So if you testing web, for example, and you see discrepancies like this in the interface, this is obviously a problem. This is a bug. But that's the ability that you have with BrowserStack. So you can just pick any device that you want. We can go with Mac, for example. You can pick the browser, and then it will just connect you to that device so you can do your testing. Because I'm on the free account, it limits my testing time to 1 minute. By the way, this is like, I just picked Safari on Mac, right? So this is how this page displayed. Again, it's also different from what we see here. But again, you can just like pick any platform that you want. When you work for a company, companies will have BrowserStack subscriptions. So you will have a limited time, right? Your time is not going to be like dying after 1 minute of testing on the device. So you will be able to test as long as you want to. So this is just a free version. That's why it's kicking me out after 1 minute. But that's the idea. Obviously, you can test any website that you want. Just provide the URL and it will take you to that page. All right, let me check the chat. Let me know if you have any questions about this. And again, if you have time, please like try to create an account on BrowserStack and explore it a little bit more. So it will be good for you. All right, let me see what we have in the chat. I see a bunch of messages. Let's see if there are any questions. Is there a way to get the full version because this account has limited time use? Yes, you can purchase a subscription. I probably wouldn't recommend you to do it right now because, again, when you start working as a QA engineer, company will buy a subscription for you. But if you want to, you can explore their subscriptions for individual use. I don't remember how much it is. I feel like it's about like $15 a month or something like that for individual use, but you can do that too. Okay. Let's see what else. Okay. If it's not very clear, maybe please clarify like what exactly is not clear. So again, I'm just navigating to BrowserStack dashboard, picking the device, and it's connecting me. But if there is something specific, please clarify what's not clear. Okay, do QA testers mainly use BrowserStack Live, or do they use any other products in BrowserStack? So most of the time we will be testing with real devices. Obviously, like 95% of the time we will be just using physical devices that the company gives us. For additional testing, we will be using BrowserStack Live if we work with web, and BrowserStack App Live if we work with mobile. So besides web testing, BrowserStack also allows you to test on mobile device. So this is another thing that you can use here. Depending on what product you're testing, if you're testing mobile apps, you will be using this. If you're testing web, you will be using just BrowserStack Live. But that's it. I will show you this too in a second. Let me just see if there are more questions in the chat before that. How you can add the platform to start testing. So here, again, you just select what platform, like what environment you use. You want to use, it's obviously just limited to BrowserStack devices. When you connect to a device, this is a real device. It's just physically located in like BrowserStack offices. So when you actually pick a computer from here, it's a real physical computer. It's just located somewhere else. So BrowserStack is remotely connecting you to that machine. So you can't like create your own, additional platform that's not here. You can only pick something from this list. Because again, it just shows the machines that BrowserStack has. So they are just physical devices. Okay, so that is web testing. Now let me quickly show you the mobile testing. So BrowserStack also allows you to test mobile devices. So if you are working for a company that's creating an Android app or iOS app, you can basically go to BrowserStack App Live project over here. And then here you can pick a device for testing. You can also upload your app. So you see here, it has like this upload button. So you can upload the app from your machine. If a developer gave you an APK file like this or IPA file for iOS app, you can just basically point to that file, click open, and it will upload the app. And then here you can pick a device and you can do your testing. So for example, let's pick Google Pixel device. Let's pick Pixel 5. And when you pick a mobile device, BrowserStack is connecting you to physical mobile device. This is not an emulator, right? So it's just remotely connecting to a real device that's located in one of BrowserStack offices. And then here you can just work with this device. You can test things. You can rotate the device if you need to test, landscape mode, portrait mode. You can change the location. This is a pretty cool feature if you're testing any kind of app that is requiring location services, or for example, that has a map functionality, like maybe online store that has a map with all the stores that they have. So here you can like simulate if you're in a different location or something like this. So it is pretty powerful. It also allows you to modify network. So for example, if you want to test how your app performs with good connection, bad connection, you can just pick it here. It's more convenient than, try to actually modify that on the real phone. It's usually pretty hard to catch. So here you can test that as well. So that's the idea. If you need to grab logs from your app, all the logs will be over here on the right side. So for example, if your app is crashing and you need to get your crash log for developers, We don't use any sort of like Xcode or ADB here because this is not our device. This is BrowserStack device. So we will have to just copy all the log lines from here. And then you basically just save them, like copy them, save them in a text file, and then you can attach that log file to your bug report. So that's it. That's basically the idea. Let me show you iOS just for the sake of example. Again, BrowserStack is usually used to increase the coverage. So in many companies, they don't have a lot of different devices. So if you need to test a device of like a rare version that your company doesn't have, this is when BrowserStack is pretty helpful, and this is when you can actually use the service. It's pretty good. It also allows you to record screen, by the way. So if you need to like record a screen or take a screenshot, it's also pretty convenient. So everything is here as well. Okay, so this is it about BrowserStack. Let me know if you have any questions. But yeah, that's all I wanted to mention here. They need to know some kind of coding language to be able to test on BrowserStack. No, again, as you can see, like all I do is just manual testing, right? I can just interact with my app over here, just like in the case I would normally test things. I can like, you know, rotate the device if I need to and do all kinds of things like that. So yeah, that's it. I'm just basically interacting with this device as with a normal device that I have. Nothing else is needed here. So just pick the device, do your testing, and that's it. BrowserStack is really helpful when you have to test on like some rare devices that your company doesn't have. So for example, just like from my experience, usually when I join a company, they have a bunch of Google devices and a few Samsung devices. But then if you need to test something on Motorola device or like some other ones, they usually never have them. So instead of buying a real device, it's cheaper for a company just to get a subscription with BrowserStack. And every time you need to test on some other devices, you can do that here as well. And for iOS, usually companies pretty much never have iPads. So they will just give you iPhones for testing. But if you need to check your app on iPad, this is where BrowserStack is pretty helpful because they have a bunch of different iPads, so you can also test on those devices as well. Okay. Would this be used over an emulator? Yes, usually yes. If your company has a subscription with BrowserStack, they will likely be using BrowserStack and will probably never do testing on the emulator. So the priority usually is physical devices, #1, because they are the best. They definitely have the same experience and interface as like for real users. Then BrowserStack and similar services would be second choice because again, they also use physical devices. It's just a little bit less convenient to test on those devices because, you know, you have to like go here and click on buttons. It's a little slow too. And then emulators will be after that. It's like our last option. Okay, cool. When you do a screenshot or screen recording, does it save it to your computer? Yes, exactly. It will just go to your downloads. Okay, cool. All right. So yeah, I think that's it. The options that are gray, are they not available for testing? Yeah, because I'm on the free trial. I'm just showing you a free version. I can't use some of the devices, but when you pay for a subscription or if your company buys you a subscription, this will be available to you as well. Yeah. Cool. All right. So one last thing that I wanted to mention here, just for your information, is that BrowserStack is not, BrowserStack is not the only company on the market that does this kind of services. There's another very well-known company. It's called SaaS Labs. That basically does absolutely the same as BrowserStack. In fact, they are their direct competitors. So what you may see for some companies that they will be using SaaS Labs, and then some companies will be using BrowserStack. Both products are super similar, like almost identical. And SaaS Labs, just like BrowserStack, allows you to connect to devices remotely and basically do your testing. So the difference between two is that SaaS Labs actually appeared on the market first before BrowserStack. So this company is older, and they managed to get a lot of like pretty big clients at a time. So you can see some partners over here. And then BrowserStack came to the market. BrowserStack had less devices to pick from, but also was significantly cheaper. So a lot of startups, a lot of new companies just started to use BrowserStack. So usually we see that older companies on the market may use SaaS Labs still, but newer companies usually go with BrowserStack. BrowserStack is still cheaper. BrowserStack has a little bit less devices than SaaS Labs to pick from, but usually companies just prefer, cheaper version comparing to like a bunch of devices that we don't really need. So that's the only difference. I'm showing you BrowserStack because it's a little bit more popular these days. But if you see SaaS Labs somewhere like maybe, I don't know, under like company description, that's something they use, or under a job description, they mentioned that that's the tool that QA is using. Like, don't be afraid and don't think that it's something that is super hard. Again, it's literally the same as BrowserStack. You just open this dashboard, pick a device and do your testing. That's it. So that's pretty much the same idea. And those are two major players that we have on the market for cloud testing. Cool. How much is SaaS Labs? Honestly, I don't remember. So you can just probably go to their website and you can explore their plans. They have different options. So, okay, so let me go back to the slides. Let me know if you have any questions. But I think this is all I wanted to mention about BrowserStack. There was one in the chat. So these are these are real devices. When you work with BrowserStack, it's connecting you to real devices. They are not, virtual machines or emulators. They're just real devices. So that's why the testing there is pretty reliable, because it's the same as if you had users with their real phones. That's it. Cool. All right. So let me continue. And that brings us to the next topic. Let's see, I don't see any more questions in the chat, so I think we can just continue with the next thing. All right, so the next topic for today is client-server architecture. Absolutely not related to BrowserStack or SaaS Labs. It's a whole new thing, so it's a whole separate topic. So let's talk about this one next. All right, so client-server architecture. So in modern world, when developers create apps, and by the way, when I say apps, I actually mean all kinds of apps, like mobile apps, iOS, Android, web pages, like web apps, desktop apps that you install on your desktop. So when developers create apps these days, they pretty much always use client-server architecture. What it basically means is that every app will have a client side, which our users will use in order to interact with the app. And then it will have the server side. So server side will have all the business logic of the app. And then in order for the system to work, client side and server side will always be exchanging the system of like requests and responses. So client side will always be sending requests to the server side, and then server side will be fulfilling those requests and will be sending the responses back. So to translate it into like more of like human understandable example, imagine the situation when you open a web page and you're trying to log in to a website, right? So you open the web page, you see like email, password field, and login button. So when you open this page and like stare at this interface, this is the client side. So the client side is the side that we will use as users in order to interact with the app. So our login page with this email, password field, login button, this is the client side. Now, the client side, like in our case, for example, login page, it actually can't contain all the information about our users. So client side, in order to find out some information, will always be asking server side. So for example, when you enter your email, your password, and you click login button, this client side actually doesn't know anything about you as a user. It doesn't know whether this information that you just entered, whether it's correct or not. Does this user exist or not? It has no idea. It can't possibly store all the information about all the users that we have. So when you try to log in here, you enter email, password, you click login button. Client side actually needs to find out whether this information is correct or not. So it's gonna make a request. It will literally copy your email, your password. It will put it into a request, and then it will send the request to the server side. It will basically say, this is user email, this is password, user's trying to log in, should I let them in, right? So now server side will capture this request, and it will try to basically understand what this user is trying to do. It will understand that, okay, this is email, this is the password, user is trying to log in. So it will validate these credentials. It will check whether these credentials are correct or not. And now if it can find user in the system and if password is correct, it will make a response, basically say, all good, like user can be logged in. So in here, you will be logged in, right? You just click on login button, request to send, server side fulfills it, sends the response, client side receives the response that everything's good, and it just logs you in. So now you're logged in and you can continue as a logged in user. Now, if, for example, you enter credentials that are not correct, we basically follow the same logic. Again, client side doesn't know anything about you. So it's just going to make a request, send it to the server side. Now, server side will understand that these credentials that you entered, this email and password, they are not correct. Like maybe this user is not found, or maybe the password is incorrect. So server side will make a different response, saying that this user cannot be logged in. So in here on the client side, you will see some sort of error message, usually like in some red color that will tell you something like this email and password is incorrect, please try again. So something like this. So this communication pretty much always happens when you work with modern apps. And very often we don't even realize that this is what's happening because, you know, we just work with our app, we click login, everything happens very quickly. But this is what's actually happening under the hood. And the time for this exchange, like request response, is very fast. Ideally, it should be less than 200 milliseconds. Most of the apps will make this call within 200 milliseconds, which is what, 1/5 of a second. And that's why, like, very often we don't even understand that there is something else besides our interface that's going on. Now, what's important to keep in mind is that there could be a lot of different client sides, and they all will be communicating to the same server or the same cluster of servers. So for example, what it means is that imagine the situation when you try to log in. Let's say you try to log into your Gmail account, and you can use your Android phone, you can use your iOS phone, you can use your desktop computer, but as long as you provide correct credentials, you should be logged in, right? So all those different clients will be pointing to the same server, and server will be just fulfilling the requests coming from all those different client sites. That's why it's important for server to be like really powerful and be able to handle hundreds, sometimes thousands, sometimes hundreds of thousands of requests at the same time. So it can literally fulfill all those requests from all kinds of different users. And the last thing that I wanted to mention here before we go into more detailed example is that when this communication is happening between client and server, in order for client and server to understand each other, we basically have to follow certain set of rules. So those rules are defined in protocol, and a little bit later today, we will actually look inside request and response, and we will see what kind of components are sent in request and response, so client side and server side can actually understand each other. One exchange of this request response is also called an API. So when client sends one request and server returns a response back, that's also called an API. So this one transaction is also called an API or API call. That's basically the same thing. All right, so now let's take a look at that with more of a real life example. So I want to go to google.com and I want to see client-server communication for google.com. So let me go here and hopefully it will be a little bit more clear after this. So when I first open google.com, right, I see this page with Google search. So this is my client side, right? This page with a bunch of buttons, other UI elements, this is the client side. Now, at this point, if I want to search for something on Google, this page, right, that's just client side, it actually doesn't know what a user is going to be looking for. It doesn't know which results to show to the user. So when I search for something on Google, this client side should make a request to Google server and basically say, this user is looking for, I don't know, for a car, for example, which results should we show them back? And then server should provide the search results so the client side can actually display them to the user. Client-server communication can be found using Chrome DevTools. So if I do right-click anywhere on the page inspect, this will open Chrome DevTools. And this tab network, this one, is the one that will allow us to see client-server communication. So again, in order to do it, I'm just doing right-click inspect. You don't have to do it, you can just watch, but just FYI. Inspect. And then here I'm going to network, right? So this one, this tab over here. So sometimes it maybe you don't see network. If you see those errors, just click here, you will see network in here. But network is the one that we will be using in order to see this client-server communication right here. And by the way, if you're opening this tool and it opens in a weird place, something like this, you can always just click on these three dots and just put it on the side of the screen. That's the most convenient for you. So I'm just keeping it here on the right side. Okay, so now you can see I don't, basically I just opened network. And now I can just do the search, right? So I can search for car. And then here I get the page with my search results, right? So this is my client side that's now displaying the search results. So if I actually look on the, on this right side under network, this tab over here, let's see if I can make it, okay, not this page. Let's see if I can make this part a little bit bigger. Here we go. It's a little hard to see, but it's actually 132 requests that were made in order to show me these results. right? So basically, when I looked for a car, this client side made actually 133 requests by now in order to just show me this search results. And you can see, like, as I scroll down, it keeps on making even more requests to just load some additional information for me. So apparently, it is faster to make a lot of small requests simultaneously at the same time, rather than like make one giant request to get all the information and then try to parse it and like display it to users. So that's why modern apps will usually do a lot of requests. So I'm actually over 200 requests now. But literally everything that is here, like all the images, all this like search result information, literally everything that's displayed on this page is actually coming from Google server. So under this network, you can actually find like literally everything that you see on this page. So I'm not gonna like look for like all the search results, but like, for example, see, this is the image that's coming from server side. There is another image. So like we can basically find everything here. So this is another image. I think I've seen it somewhere on the web, on this page. Oops. Yeah, this one is right here. So this is another one. So like you see, like small pieces of information that we have on this page, they actually were sent to us and they came from server side. So I can just like see all those things over here under network. So that's basically the idea. So again, Chrome developer tool is just the tool that you can use in order to see this client-server communication. Each one of these lines is an API, right? So each one of these lines is a request with a response. So again, there were 200, almost 300 requests made by now in order to display this information. So at this point, we just did something that is like pretty straightforward for Google, right? So we just went to google.com, we did the search, so Google handled that information and that request without any issues. Now, we don't see basically any problems with this communication between the client side and server side. But as you may guess, sometimes we may see problems. So if client side and server side fail to communicate successfully, we usually see some problems with our software. So what we can do here, we can try to break this a little bit. So I'm going to go to google.com and I'm just going to modify this URL over here. So I'm just going to basically request the URL that doesn't exist on Google. Now, if I do this, I see this page with an error, but at this point, this like communication between client side and server side basically fails because from the client side, I'm requesting this page that doesn't exist. So Google server doesn't know what this page, like it can't find this page, doesn't know it. So as a result, this communication between client side and server side is actually failing here. And if something like that is happening under Chrome DevTools network, you'll be able to see it. It will be highlighted in the red color. So let me see, here we go. I think this is it. Right, so you can see that we have like a couple of failing requests there. There's another one that failed, but this one is the request that basically is returning this error. So everything that is not successful, all kinds of errors, you can see under network, and Chrome DevTools just highlights them in red color. So that's how you can distinguish if something's not working successfully. Now, it's important for us to keep this in mind because if client side and server side can communicate, we have to have some sort of placeholder in our app that will tell our users that something's not working, because otherwise the experience will look really broken. And ideally, we need to have a way for users to go back. So for example, here on this page, they have a logo. So if I click on this logo it will take me back so I can do my search again. And now some common bugs that I've seen were, for example, pages that wouldn't display anything. So just a totally blank white page. So that's super misleading for users what to do. And keep in mind that some users are not like super tech savvy and may not even know about like this browser navigation. So if they stuck, they're stuck. So that's why it's important to have a way to basically get out of this experience. And also it's good to mention that this is an error, and like just to have like some nice message that at least a little bit explains users that something's not working. And one last thing here, I want to show you the same thing for Amazon. So let's go to Amazon, and I'm going to do the same thing. I'm just going to try to like break the URL a little bit. So we'll try to access Amazon. We'll try to access Amazon page that doesn't exist. So let me just open the URL here. Okay, and then now just modify it a little bit. Some text for everything else. Okay, here we go. And this is like what happens with Amazon, right? So if I break the URL here, Amazon also handles that. So if you have like client-side and server-side communication failing for Amazon, this is the default page that they will show to the users. So they basically say that they can't find this page. As always, there is a link to the home page, so users can start all over. And then they also have a link to Amazon blog. This is it, right? So Amazon blog lives on a different domain. It's about Amazon.com. It's not just Amazon.com. So which means that if this website is down, the blog will probably stay up because it's on a different server. This page also, like if you refresh, it also has like a new image every time. This page is kind of known in this industry because a couple of years ago, Amazon had Amazon Prime Days. And basically they hit this issue where they had so many users that their servers weren't able to cope with the load. So servers were literally just going down because too many users were trying to buy something on Amazon. So what Amazon did at the time, they actually limited the amount of people who could access the website at a certain time. And then those who couldn't access it, they would see this page. So a lot of people were actually just like playing and refreshing this page, just looking at the images. Some folks were reading information about like Amazon on the Amazon blog and stuff like this. It also went all over Twitter, but a lot of people weren't actually leaving the website, and instead they were just waiting for Amazon to go back up and were just actually playing with this website. So that's just like, one of the nice ways to retain users. And one of the nice ways to handle the situations when the client side and server side can't communicate. Okay, and the last thing that I wanted to mention here, we go back to the slide, is that when we talk about client and server communication, client-server architecture, there is actually one more component to that, which is a database. So besides client-side and server-side, we also have a database where we store all the information. It actually makes sense to separate the actual like code with the logic from the data itself. So database will be this component where companies will store all the data. If you, for example, think of Amazon.com as an example, Amazon database will literally include everything, like all the data that Amazon has. That will include all the records for users, whoever, like when they registered on Amazon, everyone who registered, their names, their addresses. If there are payments or purchases made, that information will also be stored in the database. All the information about people's past orders, all the payments they've made, all the preferred or stored payment methods, all of that will be in the database. Then for companies who sell products on Amazon, their data will also be stored in the database. So Amazon will have information about all the companies and like all the stores that are created on Amazon, all the products in every store, all the shipments made, like literally everything will be stored in here. So databases are really important, and it's super critical to keep the data secured. That's why from the client side, we should never be able to access the database directly. Also, it would have been faster, but that actually creates a giant security risk. So if someone, for example, wants to steal our data, they will actually have to hack into server, and then from server, they will try to hack into the database. So that's, again, like this architecture is made this way intentionally. So only from server, you can actually access the database and then like get some information, basically. So when I actually talk about like our login example, what actually happens when you try to log in is this. You go to the client side, like login page, you enter your email password, you click login button, client side will make a request to the server. It will pass this email and password to the server side. Now, server side will actually connect to the database and it will try to look up your user. So in the database, it has a table with all the users. And then it will try to find the user with the email that you just entered. If it can find this user, it will validate the password. It will verify that the password that you entered is correct. It's matching whatever we have here. And then if it's all good, then it will return the response that you're good and you will be logged in. If the server can't find you in the database, or if it, for example, found the email, but the password doesn't match, it will make a different response and it will tell the client side that this user cannot be logged in. So that's basically how it all works. You can think of database as just a giant collection of tables. So if you ever worked with like large Excel spreadsheets or I don't know, Google spreadsheets, that's exactly it. Like database will just have giant tables with columns and rows of data. And these tables will just contain all the information. So I'm not going to talk more about this, but just keep in mind that you will have one more lesson that will be devoted to databases only. I think it's like one of the final lessons, maybe like lesson number 18 or 17, one of those. But we will actually teach you how to get the information from the database that you need. Because very often companies actually let engineers access databases. So as an engineer, I can actually access internal database and I can look up certain data if I need to. So we will actually teach you how to do it in case you ever need to access the database and find some information, you can do it. Usually we don't really do a lot of testing using databases, but sometimes it could be helpful. So for example, if you're testing registration and you want to make sure that like all the data is properly stored, what you can do is this. You can just go to the client side, like go to the registration page. You can enter like all the data that it's asking for, like first name, last name, email, I don't know, age, whatever else it's asking for. And then when you click the register button, you can actually go to the database, find your user, and make sure that all the data made it there, that you can actually find this user by email, first name, last name, age, whatever you entered here should be recorded in the database. So this is some kind of testing that you can actually do. We don't do it really often, but sometimes it could be helpful. So you will actually have one more lesson that will be devoted to that, to this only. So that's it about like the architecture itself. Let me know if you have any questions. So yeah, I'm just gonna like answer the questions that we have in the chat. And then after that, we'll just do a quick break. Okay, let's see. they should spend a lot for security database. They do. We all do. There are a lot of money actually invested in security because major companies usually have a lot of like attempts to steal the data. There are usually a lot of hackers that try to take us down or do all kinds of things like that. So major players, they usually have whole security teams who are responsible for like tracking all kinds of attempts to hack our system, to steal the data and things like this. So companies usually invest a lot of money for that. Unfortunately, it doesn't always happen, like, you know, doesn't always help. Like sometimes you see those news about like, oh, like data leaked. So that's what happens, like hackers basically manage to get access to database and steal data. But companies try to keep it as safe as they can usually. Okay, let's see. Database would be like digital library. Yes, basically. Let's see, I think I missed one. Would a test case that has website credentials as precondition be a reason for us to use the database? Doesn't have to, right? So if you just test something with credentials, you can just limit it to using client side only, right? So for example, if I just want to verify that I can log in successfully if my credentials are correct, I can just go to login page, enter credentials, click login, and that's it, right? So I'll be logged in. That means this test case is passed. Usually, if we need to access like database, it means we're doing more of a data testing. So we're like actually trying to verify that data made it here. So for example, like registration, or maybe maybe you're testing a website that has a lot of tracking events. Like when user clicks on the button, we actually store that information in the database. Like literally modern apps store everything in the databases, including like even scroll of the screen sometimes. So sometimes some QA engineers verify that. I personally do it a lot. I hate it. But literally the testing would be like open a web page, click on the button, go to the database and make sure that there is a record about this user clicking at the button at a certain time. So something like that. Again, usually that's not what, you know, a lot of manual QA engineers do, and we don't really do it often, but that's something that would require database access. Okay. HTTP and HTTPS difference. I'm probably not gonna like go too deep into the details, but long story short, when you open a website, go back here, you see over here, it has like this lock. If I actually like click on it, it tells me connection is secured. So if I actually click on the URL, you see it starts with HTTPS. HTTPS means that this website is basically uses a protocol that is secured. So S here stands for secured, which means that it is encrypted. So for example, if I'm, let's say, if I go to a restaurant and I use a Wi-Fi, a free Wi-Fi that they have, whoever owns that Wi-Fi technically can record all the internet traffic. So when I access a certain site, right, and like this request is made, whoever has the Wi-Fi, they can actually track it. Now, if the website lives on HTTPS, it means that the data that they send is encrypted. So like, even if I own the Wi-Fi and like I go and try to look at the traffic, all I see is just the data that I can't read. It's literally just going to be the set of different like symbols that's impossible for me to comprehend, because that's like all this communication is encrypted. Now, if the website is HTTP, and not HTTPS. It means they are not using the encryption. So for example, if you are logging in on the website that has HTTP, not HTTPS, the data is not encrypted. So if you do it from a public Wi-Fi, technically someone can steal your credentials because they will literally see everything in the same way we just see it under Chrome network. So they can actually steal your data. If you access a website that says HTTP, your browser will actually like show you some warning, and it will tell you like connections not secured. Let me see if I think I may have some smaller example. Yeah, so something like this. Right, it basically says connection is not private. So usually you can click on advanced and you can still navigate to that website, so it will still work. But your browser will usually try to protect you from going somewhere that is not encrypted. Okay, this is like a little bit too deep. I kind of didn't want to go this fast, but I hope it makes sense on the high level at least. Okay, let's see what else. Is there companies that don't have database? I mean, if we are talking about like IT and tech industry, no, not really. Like pretty much everyone who has like websites, mobile apps, and things like this, they will use databases. Obviously, you know, things that are not related to tech, like some small business that doesn't have a website, they probably won't have a database. But everything that, you know, like has mobile apps or web pages, they will have databases. Cool. Yeah. Okay. Yeah. So I think it's all good. Yeah. Let me know if something's not clear about like HTTP, HTTPS, but it sounds like it's pretty clear. All right. So let's do this. Let's do 10 minutes break here, and then after the break, let's come back to this. So we will actually look at the contents of like request and response next, and I will actually show you like where you can see the data. So hopefully it'll be a little bit more clear what kind of information server side and client side exchange. So yeah, if you have any questions, just post them in the chat. For now, let's do 10 minutes break, and then in 10 minutes, I'll just start with your questions. So please don't forget to come back in 10 minutes. All right, let's start getting back to this. Let me see the chat, and then we'll continue with this. I didn't see any questions. Please ask if something's not clear. There's one question that I missed. Are the mobile app database secured? So long story short, mobile app is just your client side, right? Mobile app, web page, the interface of your desktop app that you install on your laptop. So those are just client sites, and they usually communicate with the same server, and there is only one database. The server will be communicating to the database. So basically we are like getting here, right? We have a bunch of different client sites, but then there is one server or one cluster of servers and the same database. This being said, different companies use different kind of databases. I hope they are secured, but sometimes, and we've seen that like from multiple data leaks, companies are not protective enough of their data, especially smaller startups. So sometimes like even companies with like some big names will have data leaked, and that data like is not properly secured or encrypted. Unfortunately, that happens. So like as users, very often we never know. If we use, you know, like larger stores or like companies with the name and their websites, it usually gives a little bit of hope that they actually treat their data properly. But again, it is not guaranteed. Okay. What does API stands for again? Yeah, application stands, API, I'm sorry, stands for Application Programming Interface. It's basically just a set of rules that explains how client-side and server-side can communicate with each other. So what kind of information we have in request and response, like what kind of information, for example, we should put in request so server can generate a response. So that's basically the idea. All right, so let's continue with this. Now, the next thing I wanted to show you is this. I wanted to actually go to a website, catch one API call, right? One request and response, and look at its components, just basically to see how client-side and server-side exchange data and what kind of data is being sent there and back from server to client-side. So again, we will be using Google Chrome DevTools. I'm going to be using Network. The website that I like to use is DoorDash because it's pretty easy to like find how they exchange data here. So I'm just going to go to DoorDash.com. I'm going to go to sign in. So there's a sign in over here. It opens this interesting form. And then here I will try to sign in. But I'm going to do it with incorrect credentials. So I want to catch that request and see how server reacts to that. So in order to do it, I'm just going to do right-click inspect. So I have Chrome DevTools Network, right? So right-click inspect network. And then here I will see all the information, like all the requests and all the responses. Right now, I haven't really done anything, but you see that already like a couple of calls. Most probably this is analytics. So I can actually click on every one of these lines. And for example, here I can like pick and see like what kind of data is being sent. You see this analytics, but nothing else is happening. So I can actually try to log in, right? So I'm just going to enter email, password. Again, I'm going to try to enter password that is intentionally incorrect. And then when I click sign in, I should see the request made with the attempt to log in. So let's do this, sign in. Okay, so a bunch of requests over here. Now we need to see the one that failed because login attempt failed. There are two failing ones, this first one and the second one. The first one, auth probably stands for authorization. Yeah, this is our login attempt. I know this because I've been playing with this website for some time. Usually your developers, like if you are actually looking in that client-server communication, your developers will provide you the information about which request is responsible for what. But in our case, this first one is the one that actually was used in order to log in. Now here under Chrome DevTools, we can always look at the components. So when I just click on this request, you see by default, it just opens this first tab, headers. And here I see all the information that was sent. So when we send a request, when the client side sends a request, in order for this request to be successful and for server to understand this request, our request should have certain components. So first of all, we need to have the address, which is the request URL, right? We need to know where we're sending this request. So server will be catching it and will be listening to everything that's pinging this URL. So URL is literally the address where we're sending it. So this is our first component. Besides that, when we send the request, we usually also provide request method. So request method, some people also call it HTTP verb, same thing. It's just the verb that basically describes what we are trying to do. If we are sending the information, we usually use post. Post is indicating that we are sending some data that server will need to process. In this case, I entered email and password, so server will need to look at that data. So therefore, it is post. When you, for example, go to a website and try to register, or a mobile app and try to register, the method is also post, right? Because we fill out information like first name, last name, email, password. So when we make that request, it's also post. When you, for example, comment on any website, the method is also post because, you know, you put some comment there, click comment button. So it's sending some data. If you, for example, making like some online shopping and adding something to the cart or making the payment, the method again is also post because we are just storing some information. So we're sending this information to the server. Another very common method that you can see is get. So if you see get, that indicates that our client side is trying to get information. So this is what we usually see with search. When we do Google search and look at search results, when we search product on Amazon in order to get some results back, the method is get. So get is just requesting some information. If you, for example, go to weather website to see what's the weather going to be tomorrow, the method's going to be get, because again, you are getting the information. I don't know, if you open YouTube playlist, the method's going to be get because you're just getting like list of videos or songs that are in that playlist. But that's another common word. There could be other ones, like for example, delete, update, and some other ones. But in our case, like two most common ones are get and post. So here we see post. Now, when we send the request, besides sending it somewhere and defining the method, we can also provide some additional information in the headers. So I'm just going to scroll down a little bit. See here, it says request headers. So headers just allow you to provide some additional information about this request. And headers can be very generic. So for example, like language is a pretty common header, or like content type just explains in which format we're sending the data. Or I don't know, user agent is a super common header that is usually used to track your environment. If you ever wonder like how companies actually know how many users they have on Windows versus Mac or on Android versus iOS, this is how, because every time you use the app or like mobile app or web page, they actually send user agent that's tracking the environment of their users. So in here, when I'm making this request, you can see that it's basically tracking that I am on Mac OS. This is the version of my Mac. And then it's also tracking that I'm on Google Chrome 109. So this is the version of my Google Chrome. And then headers can be custom too. So for example, here you see they have like this token that doesn't really like mean much to me, but it's a custom header for DoorDash. So DoorDash is actually using this token for something. And then if we actually need to send data for server to process, that data will be sent as a payload or request body. So if you ever see somebody saying payload or request body, it's the same thing. It's just the data that we send for our server to process. So if I click on payload here, I see all the data that was sent to DoorDash server when I made this login attempt, right? So you can see that this is what was sent: some client ID, device ID, not sure what they mean, probably like DoorDash just tracking the information about my device and my user. But then also username right here, this is my email. So literally when I enter email here, they just copy that and like put it as a username and send it to the server. And then here you can see the password. So when I enter password here, it is masked, right? We can't see it. But when we send information to server, we actually have to send the real string that user entered because server needs to process this value, right? It needs to see what password we actually entered and compare it with the one that we have in the database. So therefore, the password is actually sent right here. So if you use any kind of password manager or like store your passwords in like your computer, like this, for example, and like can fill out, please lock your computers, because like if you don't lock your computers and like someone else can have access, they can actually populate your email and password using a password manager. And then when they click send, they can just like go to Chrome network and they can actually look the value. So lock your computers, long story short. But this is it, right? So this is like the data that we send. So server can actually process all this information. Obviously, the most important pieces are username and password, so server can actually look at it. So that is the content of our request. And now when we send this request to the server, server will process that and server should return us response. Now, in order for us to understand this response, right, in order for client side to understand this response should also have certain components, so client side can actually understand what is being returned. So first component of response is a status code. So if I go back here to headers, you see here it's a status code or response code. It's always a 3-digit code that just indicates whether this, like basically what is the status of this response. And whether this request was successful or not. If you see status code that starts with 2, like 200, 201, 202, 204, and so on, it means that everything was successful, server understood what you wanted, and it's all good, your request was processed, right here, like status code 200 means all good. If you see status code that starts with 4 or 5, like 400, 401, 403, I don't know, 500, 503, and so on, it means that server side and client side, they didn't really communicate successfully. So there was something that didn't result in success. So in my case, I was trying to log in with incorrect credentials. So login attempt was not successful. So status code here is failing. It basically says 400. It means that the login attempt basically was not successful. Now, if you ever see status codes that starts with 5, like 500, 501, 503, and so on, poke around your website or mobile app, whatever you're testing. there is a really good chance that everything is down because 500s indicate that there is a serious problem on the server. So it's either a bug on the server side, or server might be down, or server might be like overloaded and can process something. So if you see 500s, like literally play with whatever you're testing, because there is a good, decent chance that a lot of things are broken. And usually if I see everything, like anything that starts with 500, I mention that to developers, so they are aware. But that's it, like status code, again, just indicates whether this request was successful or not. Then in the response, we may also get headers. So headers will just have some additional information about response. For example, here we see like the date when this request was made, the server, information about server itself. Some headers could be absolutely custom, like I have no idea what this X correlation ID is, or like X request ID is, but this is something that DoorDash has. So they are using those headers for something that they're tracking on their website. So headers could be like absolutely made up by the company and be absolutely custom for them. And lastly, if server returns us data, like returns us information, we will see that under response body or response payload. So if I go to here, response, I see what information server sent us back. It's a little bit hard to read in this tab. So Google Chrome DevTools, they have this preview tab. If you click on it, it will show you this response body, but like in a nicer way where they like format it a little bit, so it's a little easier to read. But preview and response here, it has identical information, just a little bit easier to read here. So now here we can actually see what kind of information we got back from the server. So when we try to log in, server sent us back this message. Message says, check this email for a link that will let you sign in directly to your account. Then there is a message title, having trouble to sign in. And then there are a few other things that they sent us here. Now, if you actually look at this, for example, message title, having trouble signing in, you will see that it's absolutely identical with this, right? This one that we see on the client side. And the message that we get back from the server, this one, right? It's right here. It's in our error message here. So what actually happened here is this. We made this login attempt, right? So client side captured our email, our password over here. It sent it to the server side, right? So basically this information was sent to the server side. Server validated the data. It understood that, okay, this password and email combination is not correct. So it generated the response. Basically in the response, it provided the error message that we should display to users. Now client side is getting this response, and it literally like copies whatever it sees here in the title and just pastes it so users can see this title. And then it takes this message from server and it just takes and puts it here so users can actually see it. But this is basically how most of the modern apps work. You do something in the app, client side makes a request, gets data from the server, and then just uses that data to display the interface back to you so you can work with this app. That's the idea. So again, under Chrome DevTools, under network, you can always see the contents of every request and response. So this could be pretty helpful if you try to understand like how your app works, what it's actually doing. This could be pretty insightful. Sometimes this is something that you may see during the interview. So for example, you may go to an interview and they may tell you something like this. Imagine you open a web page, you enter your email, password, you click sign in button, and then nothing happens. What could be the problem? Like, how would you understand what is the issue and like what could be causing it? So my recommendation to you here would be to say that if this is what's happening, right? I enter email, password, I click sign in, nothing happens. I would try to look under network. and see whether I have failing requests, because this is basically like the key to your success over here. So if you go under network and see that some requests are failing, you can like click through those requests and look for the one that has like this information with, sign in, and basically like check what is the status code, whether it's 200 or whether it's something that's failing, and that will give you an idea. So that's basically how you can like look a little bit more inside, like why something's not working. Some common like symptoms for client-server communication problems would be when you, for example, click on the button and then nothing happens at all. So probably there is a problem between like client server communication, it's not successful. So you click on the button and it's either request is not made or it's still like waiting, so nothing happens. So that is usually something that points out to that problem. Or for example, if you see this like spinner, like loading indicator, you clicked somewhere and it like shows you that it's loading and like nothing happens, that usually indicates that client side made a request, but it's like waiting for a response and nothing's happening. So there could be some issues there. So those would be like two really bright symptoms that usually point out the issues in like client server communication, just FYI. But yeah, that's basically the idea. So you don't need to know like all the details about like what's inside request and response, but I hope like, from the high level, at least like you can understand like where to look for the failures. So like just look for red things here, and don't be afraid to like click through payload to see what's sent, or preview to see like what you got back. So that can give you some insights about like what's actually happening, and if something's not working, you will see it there. All right, let me pause here for a second. Let me know if you have any questions. I'm gonna check in the chat, but that's basically it. Could this data be considered cookies? So in the headers, we actually get cookies. So cookies is nothing but just a certain data that is being passed between client side and server side. It's just an additional set of data that's being exchanged. And then it's basically set over here, so your client side can track you or do something else. So that's basically it. So cookies would be like sending cookies would be part of this process. And then the cookie itself is just a piece of data that client side will like save here for your future. So if you like come back to this website, if you, for example, log in successfully, client side will capture a cookie that like you're logged in, and when you come back to this website, it will log you in automatically. That's how it's done. But again, that's a little bit like too much into like technical details for manual testing. We usually don't care like that much about that, but cookies is just a part of this process. Okay. What kind of data will it show if user is using VPN? Absolutely the same data. VPN is nothing but just like pretending that you are connecting from like a different location or through like a different place. So all this data will be displayed even if you're on VPN. That's it. It doesn't modify anything here. Let's see. So who is responsible for this process? So developers will be building this. So developers who build this interface, this client side, will be responsible for like defining the logic, like when send requests to the server and like how to process the responses. So like client-side developer, like for example, web developer or Android app developer, iOS app developer, will be the person who will define the logic that like when user logs in, we have to make this request. And if we get back like something like this in response, we have to like copy it from the response and show it back to users. But that's going to be developers' responsibility. And then server-side developers, like backend developers, another word for them, are engineers who are building backend logic of like capturing those requests. And for example, if like we have to connect to the database to validate the user or do something like that, they will be the engineers who will be building that logic. So there are actually two types of engineers. There are client-side engineers or front-end engineers or developers, basically people who build interfaces, and they are web, iOS, Android. And there are server-side engineers or server-side developers or backend developers. It's all the same thing. They are people who build this logic on like what to do if client side's asking us to log in, like what kind of information should be sent back and stuff like this. So from QA perspective, we don't really care much. We just use this to see like if something's failing, to try to look inside and see like what is the issue, if we can find it. Okay, so if the number is 500 and up, that means it's an error, not wrong information that has been added. If you see 500, it's a bug. It's a problem with the server, so something's wrong with the server, yeah. 400 usually will indicate the situation when server understood the request, but the request wasn't processed successfully. So in this case, we tried to log in with email and password. Server understood the request, but it wasn't successful because data was incorrect. So it sent us back 400, which basically indicates that, okay, there is no success. In this case, it's an expected behavior, right? If I provide incorrect information, I should see an error back. But 400, like, they don't always indicate bugs, what I'm trying to say. They just indicate that request wasn't successful. 500 means bugs and the problem with the server, like all the time. Okay, let's see what else. At my job, we frequently tell the client to clear cache cookies to try to stop the spinning and or connect with the server. Sometimes it works, or sometimes it is a reboot. Yes, so long story short, if you clear cache or cookies, when your user navigates to a website or mobile app, the next time it will be like all clear. It will be similar to like just basically an absolutely clear state. So all the past data will be like wiped, and there is a very good chance that things will be working. The problem with cache and cookies is that, you know, if user doesn't clean it for ages, like for years, and we don't handle it properly from our side, there is a good chance that users has like some super old cookies that stored on their device forever, and they could be in conflict with some new cookies that we added. So cleaning it actually helps. Not usually the best solution for clients. They usually don't like to do it, but it helps. All right, cool. So now, again, this is like more for your information, just FYI, like you don't have to memorize all this like contents of request response. I have like you get overall idea of like how this whole system works, like client server and how they communicate. But now I wanted to share a little bit more information about the actual status codes, just in case like maybe you'll need it one day. So all the status codes, right, all these codes that we see here, they actually are pretty standard, and they all can be divided in 5 different groups, which, to be honest with you, like in my life, I pretty much always just see only 2 of these groups. I know the other ones exist, but they are like not super common. So Usually, when you work with like client-server architecture, if everything is good, we see status codes that start with 200. So 200 level responses, they basically tell us that request was received, it's understood, and everything is good. So if you see 200, it's basically indicating that everything's working. Now, another common one here is 400. So 400s indicate that server understood your request, but it wasn't processed successfully because server thinks there is like some error coming from the client side. So for example, when we try to log in with incorrect credentials, like server understood what we were trying to do, but request wasn't processed successfully because we sent incorrect data. When we, like earlier today, were trying to open a Google page that doesn't exist or Amazon page that doesn't exist, server, again, it understood what we were trying to do, but it believed that we were requesting for some invalid page. So status code was 400, 404, it was in that case. Again, if there's server problems, you will see 500. So that's another one that you may see. Usually it's quite rare because servers usually like built to be really solid. But if you see 500, that means that there are server issues. But all the status codes, you can always look up. And again, they are pretty standard. So on this slide, slide number 9, I added the common, like the link to the common status codes. So it basically takes you to Wikipedia where every status code is described. So if you, for example, like testing something and you see certain status code that you don't know, like for example, here, I think on DoorDash, like this request is not successful in status code for 29, you can always Google that status code, or you can just go to Wikipedia and try to look it up. So like, for example, here under 429, we can actually find it. And we can see like what kind of problem that status code indicates. So for example, here, 429 basically says that there were too many requests sent, so server like wasn't able to process it. So if you see some status codes that you don't know, just Google them, and that will like help you to understand like what kind of issue is happening. Please don't try to memorize them. Even backend developers don't know them by heart. Obviously, some status codes will be super common, so you will kind of remember them. When you start working as a QA engineer, 200s is pretty much what we get like 99% of the time. It means that everything is working. Or common errors will go like 400, 401, unauthorized, 404, and things like this. But some status codes are barely even used. I don't know, my favorite is 418, super helpful. But, like they exist. So if you're curious, you can always just find them. So don't like bother memorizing them. Just keep in mind that 200 means good. It's all okay. 400 and 500 indicates the errors. And then if you need a particular status code, you can always look them up. Now there is my favorite resource that I also like to share. There is a website that describes every possible status code with an image of a cat. It's called HTTP Cats. So if you're curious in like finding out more about status codes, or just like seeing some more like fun content related to that, that's a fun website to explore. There is also a similar one with dogs. So if you are curious about that, you can also like look it up and you'll find that as well. But that's pretty much it about status codes. Okay, and I'll probably just drop it in the chat just for fun. And the last thing that I wanted to mention here is that this communication, right, this client-server communication actually can be tested. So as a QA engineer, you can actually test this communication, like you can actually send the requests yourself get the response from the server, and you can validate that and make sure that when you send in a request, the server processes that properly and gives you back the correct information. That kind of testing is called API testing. So API testing is the process of like sending these requests ourselves and then validating the data that we get back. In order to do API testing, you actually don't need to know any kind of like programming language. You can do that testing manually. You just need to learn how to work with certain tools that allow you, just like the client side, basically they will allow you to create a request, like fill out this information, send that request, and then get back the response and validate what's coming back to you. The most common tool that is used these days is called Postman. If you've ever seen Postman or heard something about it, that's basically what this tool is used for. It allows you to make a request, send it, get back the response, and then like look at what data you're getting back so you can validate it and make sure that you receive the information that is correct. So if you are interested in that, we actually have a small API testing course that you can also take. It's free, first of all. So this is basically how it looks. So if you are interested in this, just feel free to explore it. This API testing course will be just available to every one of you through your course dashboard. We usually turn it on like at the end of this course. You can like try to access this link, but if it doesn't work for you yet, that's probably because it's just still not open, but we usually just turn it on for everyone at the end of the course, so you will just get access and you can just watch it and you can learn how to do API testing yourself. You don't have to. This is like more of an addition, but again, if whatever we talked about today, like client-server communication, request response kind of makes sense on the high level, I would encourage you to actually like go through our API testing course and try to learn like how you can test APIs. This is a really good skill to add to your resume. Not many manual QA engineers know how to test APIs. So if you do, that's really a huge advantage comparing to the rest of the market. This course is recorded. So basically it's just like 5 or 6 videos, something like that, that you can watch. And then during that course, first of all, I explain everything that I covered today, but also I explain how to use Postman, how to create test cases only like for client-server communication, how to report bugs, and things like this. So again, if you have time, I would encourage you to check this one out because it could be helpful. And the last thing that I'm supposed to tell you here is that we also have few more videos, like 2 more videos that we recommend you to watch. This is not related to API testing, but this is 2 videos devoted to some other tools that people use when they do testing. One of the tools is Charles Proxy. It allows you to basically see this network, but for mobile, right? So today we were just doing web with Chrome DevTools. Mobile apps also send the same request responses, but Chrome DevTools doesn't allow you to see what they are sending. So for mobile, you will be using other tool if you want to see this kind of communication, and it's called Charles Proxy. So we have a video here about how to use Charles Proxy if you ever need to do like this and see this client server information exchange. So please watch this video. And then there's another video like basics of Unix commands. So that's another tool that could be helpful in testing. So if you have time, like please explore these 2 videos as well. And keep in mind that, you know, this course is coming too, so you can watch API testing at the end of this course as well. So this is it. That's all. Yeah, that's all I have for today. Let me know if you have any questions. We have about 5 minutes left, actually a little more. So yeah, I'll be happy to answer. And yeah, all the information is here on the slides. Cool. What time can we join API course? So maybe check out this link if it works for you or not. If it's still locked, then it will appear for you at the end of the course, but we just give this course to literally everyone who joins manual. Like manual testing course. So if it's locked right now, just take this lessons at the end. Like after you complete manual course, you can just take those lessons later. If it's open for you right now, you can just watch it at your free time. So again, it's just like some pre-recordings, right? So you can just watch it at your own pace, your own time. So all the materials are here. Okay, cool. Yeah, it's great that all is clear. I hope it is. If it's not clear, by the way, I know like usually we have at least few folks for whom this is really technical. That's okay. You always have the recording. You can always just like rewatch it later. That's totally fine. Like I know this could be a bit too technical for some folks. That's all right. Just like maybe rewatch the session later. It'll get there. Did you learn API testing before or after landing your QA job? Well, to be honest, I would say, probably a little more than 10 years of experience in QA. So when I was looking for my first job, we had like way less requirements for QAs back in time. Back then, like literally all you needed were just like, being able to create some test cases, know like some different types of testing. No one was even asking for like, ADB commands or like what is like a log file or Xcode or things like this. Like over the past few years, market really shifted. So like we now see some jobs that actually are asking for like more advanced tools. So that's why in this course we cover like way more technical aspects. So I actually learned API testing, I would say, after I started to do a little bit of automation. So I did like some manual testing, then I started to do automation. And then at some point, I needed to do server-side automation, and I didn't know anything about server-side logic. And that's when I started to dig into API testing. So that's the story. Okay. Can you please explain how I can copy the information that I found to a bug report or Jira? So if you just copy, certain text, you can just create a text file on your computer, and then you can like attach it as a Jira. Like Jira has attach buttons where you can like put attachments. If you, for example, attaching a video or screenshot, you can just click attach and just upload it there. Or if you're copying some data, from a website or something, you can just like copy from here, right click copy, and then like go to Jira ticket and just do right click and paste. You can do that as well, but that's usually it. How different is manual QA comparing to automated QA? So manual testing is more of like actually touching the product and working with the product. Automation is usually just building automated tests around it. So automation requires some coding experience. With automation, we just use programming language to write the test cases, right? So in manual testing, you'll just go to test trail and create the test case there, like navigate to a web page, I don't know, click this button, verify that you're logged in. In automation, we'll do the same thing, but we will just use a programming language. So I will write like logic in like programming language to open a web page, click on the button, and then verify that I see certain text or verify that I'm logged in. That's it. Manual testing, basically, I would say a little bit more creative, like you actually get to play with the product more. Automation from that perspective is a little bit more boring because you usually, like, we are given a set of test cases that manual QA engineers created, and we just translate those into code. That's it. I do a mix of both actually right now. And like when I take jobs, I usually look for jobs where it's not just like only automation, but at least a little bit of manual testing, because I don't know, I get bored with only automation. So I look for jobs where that's at least a little bit of a mix. Is the purpose of finding the error to do a bug report, right? So the purpose is, how do I explain it? So basically, let's see. Okay, we have 2 minutes. Testing is just about like verifying that something matches your requirements or your expected behavior, right? You have a set of requirements, like this is how things should work. And then you have some expected result, right? So if I click this button, I should be logged in. Now, basically, when you test things, you just execute the test cases. And if your app actually behaves like it's defined in the requirements, it's all good, it's passed. If it doesn't, it's a bug. That's the definition of a bug. The bug is a mismatch between expected behavior or requirement and the actual behavior, right? So if it actually does something that it's not supposed to be doing, this is a bug. Now, when we find a bug, we report it in Jira in order for developers to fix it. So the end goal here is to discover the issues so developers will fix them and the product will be better. Or maybe they will not fix them, but at least we will all know that these issues exist. And we're not going to be, surprised when users start complaining about something. Not every bug will be fixed. So QA in general is about like understanding risks and basically trying to basically influence other folks to make the product a little bit better. So like all this testing is just the tool, and the end goal is to understand basically the overall state of quality, like how good the app is, and point out the problems so these problems will be fixed, right? So the end goal is basically to improve the product. This is how I would define it. Some people may have some different opinions, but that's my point of view. Okay. Will students have access to the videos and materials after graduation? Yes, as long as you need to. And by the way, if you ever lose access for some reason, just ping our support and they will just re-enable the access. So you get those materials as long as you need to. Cool. All right. So let's see. Yeah, I'll just stick around, I guess, for another couple of minutes and answer the remaining questions. If you don't have any questions, feel free to drop off. Totally, that's I don't want to hold anyone. Thank you, everyone who joined. Thank you for good questions. I see a couple more questions, so I'll just answer them. But feel free to drop off. We're pretty much done with what we needed to cover today. Okay, let's see. Did you have programming experience prior to you starting your QA career? No, I didn't. My background was actually in economics and linguistics. I was working for Citibank for some time, basically. And at some point, I heard, about opportunities with tech. I was really curious. I was also a gamer at a time, and basically a friend of mine had an opportunity, basically testing opportunity in a gaming company. So I joined that company as a QA engineer, was basically just playing games and telling them what is broken, what is good, what is not. And from there, I actually got that's into manual testing. Then I switched to more serious company, was doing some manual testing there. And then I switched to automation. That's basically the path. How difficult is it to learn automation QA? It depends. So from our QA automation course, we do have students who actually manage to learn everything before other folks. So within a couple of months. And then we have people who actually retake the course. So it takes them about like a year to do it. I would say in average, it usually takes about 4 months. So like most of the students just take our QA automation course. They take like about 3 months to fully complete it, and then like spend some time with mentors to like practice interviews, coding challenges, and stuff like that. But it really depends on your background and previous experience. Folks who like have some previous experience in like programming or development, or even just like some manual testing experience, they tend to finish automation a little faster and learn it. People without like any background usually take a little bit longer. But again, it really depends on the person. And like we once had a guy who was a musician, and he just went to automation, nailed it. Basically like was going ahead of class, asked us to provide the recording from past course so he could actually go ahead of everyone. And then he like got a job within 1 month. So that was, I think, the best like result from the course so far. And absolutely like no experience. He just really liked it. But in average, I would say around 4 months. Okay, cool. So let's see. I don't see any more questions. I think I answered everything. So yeah, thank you everyone for joining today. Have a good rest of your night. I'll see you later in this course. Bye-bye. Thank you.